I'm pro polyphenol. Tell me why we should maybe rethink the whole polyphenol thing.
And I was pro polyphenol in the past, and I think that the polyphenols are perhaps the thing that most people in the space will have the most concerns about, or where there's the most active discussion about. Sure. The polyphenol thing is a little bit more sticky. It's kind of this bramble patch to weed through it, but I like what you said about beginner's mind. So if we just back up from the polyphenol argument and try to forget everything that we've been taught about them or heard about them, and just think about it this way. Polyphenols is a term in organic chemistry that means multiple phenol residues. Phenol is an organic 6-membered ring, so it's 6 carbons with a aromatic structure, which means electrons are shared. It's a hexagon with sort of these lines in it. If you look at the organic chemistry diagram, meaning there's aromatic structure and it has a hydroxyl group, so it has an OH group. That is a phenol. Polyphenol is a class of molecules that are organic molecules that have multiple 6-membered rings and aromatic structures. Now, polyphenols, kind of like cholesterol, polyphenols is a general term that doesn't always accurately describe what we're talking about. What we're really talking about when we say polyphenols are really plant compounds. But a lot of plant compounds we're talking about are not polyphenolic. Like isothiocyanates, for instance, sulforaphane is not a polyphenol, but it's a plant compound. So if we expand the discussion to just talk about plant compounds, that is the correct term because they're not all structured that way. But that will include things like sulforaphane, resveratrol is actually polyphenolic, curcumin is actually polyphenolic, but some of the compounds we'll talk about are not polyphenols. So if we're talking about plant compounds, let's just back up a moment and think about it kind of on first principles. Plants are rooted in the ground. They don't have really much interest in making themselves tasty, nutritious, or easily obtainable to animals at all. Most polyphenols and plant compounds are actually plant defense chemicals. They're plant defense chemicals. They're called phytoalexins. Sulforaphane is a phytoalexin. Resveratrol is a phytoalexin. Resveratrol is a molecule that plants make to defend themselves against insects and fungus. It's not a molecule that plants make to benefit an animal eating them. So we just need to remember that these are molecules that plants are making for themselves. The broader context that I try and elaborate for people is the idea that these are different operating systems. We kind of touched on that in the beginning. Plants have a way of doing things, and animals have a way of doing things. And these are very different, and never the twain shall meet. These are really like computer operating systems. You have Mac and you have PC, and you can decide which one is human, whatever your bias is. I think of humans as Macs and plants as PCs. That shows you where my bias is because I have a Mac. But there are different operating systems. So plants are kind of doing their thing. They're doing their biochemistry. They're using polyphenols and plant molecules for defense purposes usually. Sometimes they are pigments. Flavonoids are another part of the polyphenol family, and they're often pigments. But people need to realize these molecules are not designed for animals by plants. This is not a symbiotic relationship. There are symbiotic relationships in nature. This is not one of them as far as we know. And I don't really think that's debatable or an opinion. That's really scientific fact as we accept it at this moment in time. This is not a lichen. This is not a bacteria and a fungus working together. This is plants doing plant things and animals doing animal things. And the majority of the time, these molecules are plant defense molecules against insects, against fungus, against animals. So just at that moment, if we just pause there and think, why would we think these were good for us? And I think that the way that we approach the research to polyphenols is a little bit wrong. We have an assumed hypothesis. We have an assumed paradigm that these molecules are going to have benefit for humans. And I would argue we need to probably take the other position, the complete opposite position, and say, I wish that the burden of proof were on the researchers to show, hey, you prove to me this is beneficial because I don't think the plant wants it to be beneficial, and generally it's doing that to poison me and everything else eating it. So we better do a lot of research to make sure that's really beneficial, because just the way it's designed is not as something that is beneficial for anything except keeping the plant alive. Why did we think polyphenols were good for us in the first place? Why do we think plant molecules were good for us in the first place? Because if you look across the molecules, if you look across resveratrol, if you look across curcumin, if you look across other plant molecules that people think of as beneficial, the same pattern is invariably there. There's this pattern of a few studies maybe showing a benefit in one aspect, but they're just like this little tiny, this little tiny space, and they're saying there's a benefit here. But if we look at the sum amount of literature, we can always find other places in the human body where they are causing harm. And this little benefit I've never seen a benefit that's unique to that molecule. It's something that we can achieve in other ways in our life. So it's kind of a complex concept, but it's a redundant benefit with other collateral damaging effects. So clearly
studies ignore.
That studies ignore.
Or people looking at the studies don't look at, or are unwilling to, because they're looking at the positive side.
They're looking at the positive side. And then I think that for many of these, we're just not considering the overall effect of these molecules. So that's a little bit different perspective on polyphenols and plant molecules. Like, what is the net effect in a human? And from what I've studied, I'm just not convinced that there's a plant molecule out there that's a net positive for a human. They may have a benefit in one space, and we can talk about resveratrol if we want, but like sulforaphane, it's going to increase your glutathione because it's a pro-oxidant. But the downside of that is if you get too much, you can definitely overwhelm your body's ability to make glutathione. Then it's going to become clearly a pro-oxidant. It's clearly a toxin. And it's doing all these other negative things in the human body. And the one positive effect, you didn't even need it for in the first place. So it's clearly net negative. And then you say, okay, well, what are the other foods I can eat that don't have a net negative? Well, animal foods don't have toxins like this, right? They haven't evolved because animals can run away or bite you.
Right. Gosh, that's super fascinating, because I think the pro side of the polyphenols is they think that process is beautiful. Like, wow, you get this myrosinase and glucoraphanin, and then your microbiome can make the myrosinase as well. And it's actually a mycotoxin that has a xenohormetic effect. So you definitely, you hear about the upside, but it does make sense. You're like, wow, broccoli sprouts, they're at their most vulnerable, and so they don't have the tools or mechanisms or the stability to evade predation or whatever. Wow, so this is, I think it's important, wherever anyone is on the dietary spectrum, I think it's important to hear both sides. Because if you just hear what you want to hear more of, because that's what I found with the internet particularly, is people just seek out more of the same. They want to confirm their biases and hear more of the same. So I think it's great that we're having this conversation, because